Next, concurrent deviation method. So this is for to measure the correlation coefficient between the two variables. So we know that what is the meaning of correlation? Correlation is nothing but a relationship or connection between two variables. So that two variables may be demand price or demand income level or any two variables which are affecting the situation. We are gathering the set of information regarding the variables. Then after that, what is that impact of one variable on another variable? So here we are going to discuss related to the correlation. Now coming to the next method of this concurrent deviation. Before this, already we discussed two methods. What is that Carl Pearson coefficient of correlation, at the same time Spearman's rank correlation. So when we have the individual observations have given, we can use the Carl Pearson coefficient of correlation. When we have the ranks between the marks or etc., means when we can give the ranks to the observations, we can use the Spearman's rank correlation. So coming to the concurrent deviation method, here when we have the pair of observations will be there. By comparing the pair of observations, the direction of the change, then we can use this concurrent deviation method. So here we have the formula for concurrent deviation method, that is RC, nothing but correlation coefficient, or correlation of R is equals to plus or minus under root plus or minus 2C minus n by n, where C is equals to number of positive signs after multiplying the change of direction. So here we are going to multiply that change of direction. How? If the direction moves the positive side, means for example, if we are taking this example, here series, here of series X and series Y. So here first year 2003, 2004, 2005, 2006, 2007, 8 and 9. So here we have the series of cash flows or series of sales we have given for X product and for Y product. In X for 2003, 150, 154, 160, 170, like this we have the information. So by observing this information, so what is the impact of this information we are going to find out. Here the C is nothing but number of positive signs after multiplying the change of direction. So first of all, we have to compare these two observations. Okay, so here we have to do the pair of observations here X and Y. We need to identify the correlation between these X and Y. What is the X series and what is the Y series? So here after making these directions, means for example X 2003 sales are 150, so 2004 are 154, means it for moves positive sign, means it moves increased. If the movement is increasing, we can take as a positive sign. If movement is decreased, we can take it as a negative sign. So here the positive sign, that is the number of positive signs after multiplying the change of direction, that is called to C, and n is equals to number of pairs of observations, means how many number of pairs we got observed. So that we have to take it as a consideration. From this formula, make the solution for this with the help of concurrent deviation method, we can give the correlation coefficient for this problem. So here 2003, 4, 5, 6, 7, 8, 9. Here we have n number of, means here 1, 2, 3, 4, 5, 6, 7 years of data we have. Here X series of and X series information and Y series information here we have. So what we have to do here, first of all, we have to find out the dx and dy. To collect means to calculate this dx and dy, we need to identify the direction. So for example, what about the 2003 sales 150? So either it may increased or it might be decreased from 2002. So we don't have the information, then we should left it. First point we have to left. Okay. Then we have to left, means we have to make it as a cross. So star. Then we should not compare this. Why? Because there is no previous information. Then coming to the 2003, 150 to 154. Then it is increased. If when cash flows are increased, or series of sales are increased, the information is increased, the data is increased, then we can take it as a positive sign. Then 154 to 2005, 160. Then again it increased, plus 160 to 172. Again it increased, plus 170 to 160. Then it is decreased, minus 160 to 165. And again it increased, plus 165 to 180. Again it increased, plus. Then this is for dx. Similarly dy. So we don't have the information for previous, then we put it as a star mark. Then 200 to 180, it is decreased. Then 180 to 170, again it's decreased from past year. 170 to 160, again it decreased from past year. 160 to 190, it's increased. Then 190 to 180, again it's decreased. 180 to 172, again it's decreased. Then if the cash means that its variable value is decreased, we have to put as a minus sign. If the variable value has increased, we have to put it as a plus sign. So similarly, what about here? We have to do dx and dy. So star, there is no information. So put it as again star. Then plus into minus, minus, 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 plus into minus, minus. So all these are minuses. Then C is equals to what is that? Number of positive signs after multiplying the change of direction. There is no positive sign here. So C is equals to 0. Then coming to the N is equals to, how can you find out this N? How many number of observations we have compared? So here 150 to 154 compared one. 1, 2, 3, 4, 5, 6. 6 times we have compared with previous one. So N is equals to 6. So clear? Means this star will be not compared because in the first year 2003 we didn't have information about the 2002, so we didn't compare. Only we compared from 2004, from 3 to 4, that is plus, means increased 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8 and 8 to 9. 6 times we got compared, that is N is equals to 6. So C is equals to, there is no positive signs after deducting this, after multiplying this dx dy, there is no positive signs, that is equals to C is equals to 0. Then we can substitute these values into this RC. RC is equals to, what is the formula? Plus or minus under root of plus or minus 2 into C. C means 0, 0 minus 6 by 6. Okay. So 2 into 0, 0. It implies plus or minus at the root. How much it is? 2 into 0, 0. Then 6 by 6. 6 by 6. This is equal to minus 1. Okay. So plus or minus, here we have minus 6 now. Minus 6 by 6 minus 1 under root minus 1. So here minus 6. Then what is the information? What we have? Minus 1. Then RC is equals to minus 1. This is perfectly negative correlation we have. Perfectly negative correlation between these pairs of observations. So that is the information related to, that is a problem related to concurrent deviation method. So what we did here, RC is equals to plus or minus under root of 2C minus N by N, that is the formula. Then C is equals to number of positive signs after multiplying, change of direction. Then number of N is equals to number of pairs of observations. So here clearly, here 2003, 4, 5, 6, 7, 8, 9, then 150, 154, 160, 172, 160, 165, 180, then 200, 180, 170, 160. So this is the information we have. So if that means, first of all, we have to compare this 2003. There is no to compare that information. We don't have the information about the 2002. So left it 2003. We have to left. Then 2004. Then 2, 3 to 4, 150 to 154. It is increased. Then we have to put positive sign. Then again 4 to 5, 154 to 160. Again it's increased, positive sign. 160 to 172, positive. 170 to 160, then it has decreased. Because of this, we have to put negative sign. Then 160 to 165, positive, because increased. 65 to 80 increased, again we have to put positive. Similarly, we have to do Y 200. There is no information from the previous year, that's why we put it as star. Then in the 2004, from 3 to 200 to 180, minus 180 to 170, minus 170 to 160, minus 160 to 190, plus 190 to 180, minus 180 to 172, minus. Then again we have to multiply dx dy, plus into minus, minus, plus into minus, minus, plus into minus, minus, minus into plus, minus, plus into minus, minus, plus into minus, minus. All the minuses, there is no positive signs. If any positive signs will be there, we have to take it as a value is equal to C. We have if we have two positive signs, we should take C is equal to 2. But here there is no positive signs, then we have to take C is equals to 0. Then we have to substitute that in the formula. RC is equal to plus or minus 2 into C is equal to 0 minus 6 by 6. Minus 6 by 6 is equal to minus 1. Under root minus 1, that is equal to 1. So that is RC is equal to minus 1. Perfectly negative correlation here we have. So that is the what is that concurrent deviation method. Next, one more example we'll consider for this concurrent deviation method. So here we have the information here 1, 2, 3 months and average number of workers X we have taken it as, and sugar cane consumed Y. X and Y values we have taken. So there the observations are 1, 2, 3. How many months we have taken? 12 months in a year. Then 320 workers, 310, 310, 294, 280, 270, 240, 212, 245, 300, 364, 336. So here these are the workers, number of workers, and here the sugar cane consumed. So 24, 22, 20, 16, 15, 13, 12, 12, 16, 22, 27, 24. So here what we have to do again, same dx, dy, then dx, dy. We have to calculate. So for this dx, dy, we have to compare. So to compare this first year, we don't have the information. The similarly, we should put it as a star mark. Then coming to the second year, 320 to 310. Decreased, minus 310 to 310 means same is equals to same 310 to 294, minus 294 to 282, minus 282 to 270, minus 240 to 270 to 240, again minus 240 to 212, again minus 212 to 245. Here we have the plus increased, 212 to 212 to 245 increased, then 245 to 300, again plus 300 to 364, again plus 364 to 336, minus. Then similarly, how many observations we 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Done. Next, coming to the second dy, that is sugar cane difference. First is star 24 to 22 decreased, 22 to 20 decreased, 20 to 16 decreased, 16 to 15 decreased, 15 to 13 decreased, 13 to 12 decreased, 12 to 12 equals to 12 to 16 increased, 16 to 22 increased, 20 to 27 increased, 27 to 24 again decreased. Then coming to dx dy, minus into star star, minus into minus, plus is equal to into minus, minus, minus into minus, plus, minus into minus, plus, minus into minus, plus, minus into minus, plus, equal to into minus, minus, plus into plus, plus, plus into plus, plus, plus into plus, plus, minus into minus, plus. So here nothing but C is equals to how many positive observations? 1, 2, 3, 4, 5, 6, 7, 8, 9. Here C is equals to 9. Coming to how many number of pairs of observations we have to compare here? How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. N is equals to 11. Then we have to substitute it into the formula. C is equal to plus or minus the root plus or minus 2 into C. C is equals to 9. 2 into 9 minus 11 by 11. Then plus or minus under root 9 into 2. 18 minus 11. 18 minus 11, nothing but 7 by 11. So 7 by 11. So how much it is? 7 by 11. It is positive, purely positive, 7 by 11. So root 7 by 11. 11, 7 by 11 ante 11 means 11 ones are 0.77. Okay. So plus or minus under root 0.06. So that is the answer we have getting with the correlation coefficient of this concurrent deviations method. So plus or to simplify this root value, we will get some positive value, approximately positive value we will get, because this is what is that root, in the sense in the root we have the positive, then we will get the positive, then always this is positive correlation between these variables. Okay, this is a one more example for the concurrent deviation method.